Good morning, friends. Welcome to Water Resources Engineering class. So, we have started the fourth unit. And what are the basic things of groundwater hydrology? Yesterday, we have dealt all those things. So, in today's class, we move into more important things in the same unit, groundwater hydrology. So in today's class, our focus is mainly on the Darcy's law. So coming to the Darcy's law. Darcy's law is the fundamental equation in groundwater hydrology. Anybody, when groundwater hydrology, first question anything has to be given, or first question which has to be asked to the students is, what is Darcy's law? Because that is the equation from where the entire analysis part of the groundwater starts. So what is that? It describes that the flow of water through porous media, mainly through the soil pores, how this water travels. So that is being given by Darcy's law. Porous media is nothing but the soil structure. So through soil, how the water flows, that is being given by Darcy's law. It has been experimentally derived by, or experimentally done or given by Darcy. What is that statement of that Darcy's law? The rate of flow per unit area is proportional to the hydraulic gradient. Rate of flow per unit area is proportional to hydraulic gradient. So per unit area, if I take it on the other side actually, so it is proportional to hydraulic gradient into area, or Q by A is proportional to I. This is what the Darcy's law is. Or Q is proportional to IA, or Q is equal to some coefficient into IA. So this is finally what Darcy's law is. That's what I have specified. The rate of flow per unit area, or the discharge per unit area, is proportional to its hydraulic gradient. But of course, there are certain assumptions. Fundamentally, Darcy's law is valid only for laminar flow. It is valid only for laminar flow conditions. So what are the different things? Q is the rate of flow or discharge. You know the units also. And K is the Darcy's coefficient. And this is also called as coefficient of permeability. Coefficient of permeability. And it is expressed in velocity units, meters per second. Already we explained in the previous class what is coefficient of permeability and all. The next one is I is the hydraulic gradient. A is the total cross-sectional area of the soil mass perpendicular to the direction of flow. If suppose this is the soil mass, the area perpendicular to the flow direction. Please remember, it is the cross-sectional area of soil mass perpendicular to the flow direction is what we call it as area of cross-section. V is flow velocity. Finally, what is Darcy's law? The rate of flow per unit area or the discharge per unit area is proportional to hydraulic gradient, or Q is equal to KIA, where Q is the discharge in meter cube per second, K is the coefficient of permeability in meters per second, I is the hydraulic gradient, A is the cross-sectional area which is of the soil mass which is perpendicular to the direction of flow. What are the assumptions of Darcy's law? First thing is the soil medium. Whatever medium you are choosing is nothing but the soil. The soil is homogeneous and isotropic, right? That means all the properties in all three directions are same basically. The flow is steady and laminar. Basically it is laminar flow, and we are taking up only steady flow actually. The soil is fully saturated. Only whatever we are talking is only saturated zone. We are not talking anything about the unsaturated zone or voodoo zone. The hydraulic gradient is uniform. The hydraulic gradient is more or less uniform actually. The fluid is incompressible and has constant viscosity, because same fluid is flowing actually. Only we consider the water only, then only we consider the viscosity remains as constant and the water is incompressible, the same. So once again, what are the assumptions of Darcy's? So it is homogeneous and isotropic, steady and laminar flow and fully saturated, and hydraulic gradient is uniform, and so the fluid is incompressible and has constant viscosity. What are the limitations of this Darcy's law? It is not valid for turbulent flow. The moment I told that it is valid only for laminar flow, automatically it is not valid for turbulent flow. Then for the unsaturated soils, naturally it is not work out. So similarly, at a very low gradient, flow may cease due to threshold gradients. That means if suppose in a fine grained soil, if suppose the low gradient, hydraulic gradient is very low, then flow may not be there at all. That is one of the limitation actually. So here we have given one small calculation example. If suppose you take K is equal to this, hydraulic gradient is this, area is this, how to find Q? Nothing but just Q is equal to KIA straight. So this is as far as the Darcy's law is concerned. So we have completed the Darcy's law basically assumptions, and Darcy's law limitations actually. So this completes to me. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.